Hello, we're gonna do an STM32 example also today, which is going to be based on communicating with the external world. So we're gonna do something again, such as a blink LED example, but this example will also interface with the outside world. So first thing we have to do is plug in our device. Next we will have to find a program called PuTTY from the Microsoft Store. That's an executable file that you need to open up, and you have to do some configuration with that. Now in this configuration file you will have to write in the serial line that corresponds to the device that you're communicating with. So you have to find that out. That happens to be COM6 for me. So what you have to do is you have to go to the search bar, and from here you have to type device manager. Open up device manager, and from here you will see a lot of interfacing devices in the port section. So from the ports you will be searching for STM device that you have plugged in. That happens to be COM6, communicated through COM6 for me. So I know that I can communicate with my device through COM6. So once you have that information, you can write that into that serial line slot on the PuTTY, and you need also the speed that needs to be inputted. You can safely write 38,400 into that slot. It's going to be a serial communication, and from this point on you just say you can save this configuration for future uses, and you can open up that communication through COM6. Now you have actually a communication line through that port using UART to our device. At this moment you have to set up, once you have finished setting up PuTTY, you can open up your application and start up a new project to communicate with this port that you see at the output. That's going to be a new project from scratch. So at this moment we come here and open up a new project, new STM32 project from the top menu, as you see. Just does the usual initializations. Again, you select your target depending on the device that you're running. My device is here with this Nucleo board, STM32F303, but yours might be different, so you have to select the right device and you click next. Open up a new project. That project name can be LED button with an output for the terminal, so I just say LED button terminal, and it's going to be a C project. I click next and I click finish. I have nothing else at this moment. It opens the usual IOC interface that you always see. Takes a while for me, but it finishes up. I have my chip in front of me at the moment. Now all you have to do is do some initializations on the ports. I know that port A5 is my output, so I set it as output. Port C13 is my input. And after these are completed, I have to make some initializations also for the connectivity part. So I have to have the UART set up for that purpose, and I know that UART 2 is used for external communication with the outside world. UART 1 is already occupied with the debugging operation, so I cannot touch that, so it has to be USART has to be selected. Now we're going to set that as asynchronous enable for USART, and I need to have in the configuration window, I need to have the USART has to be enabled for the interrupts. So you're going to have an interrupt generated, interrupt routine has to be generated for that purpose. There is no other things to be initialized, but as you see that port A2 and port A3 are already occupied with USART, so you cannot place anything else into those slots anyways. So the next thing that you should be doing is to enable the debugging through sys. Through sys. That's going to be a serial wire debugging. That's what you have set up as your debugging method. That's going to be a serial debugging, serial wire debugging enabled. And you, at this moment, what you have to do, you just click save. There's nothing else left. So save your file. So it generates a new configuration file for you, a new main.c for you. And we'll go ahead and write something into that main file as well, because we want some tasks to be completed along the way. Now, what I want to do is, the first thing is I would like to add some information into the lines between user code begin PV, right here, some information. So in this line I'm gonna add the data that I would like to print out. So I need some initializations at this moment. So I have a buffer to be transmitted when I press a button. I need to have a string to be printed out on the terminal. So this is what I print out at the output. You press the button, and I also would like another statement to be printed out when I first initiate the code. That's going to be welcome to Hacettepe. So those are the two initializations that I need. What else do I need to have here? Let me check on that. I'm gonna have, see, as you see, there's a UART handle type def HUART 2 has been defined for communication by the STM32. Then let me come here and type in my while code content. So it's going to be between the while one statement down here. So I need to find that part that I can write my code. So this is the part that I'm going to be writing my code in. So let me type that in very quickly. Yep. So it's right here. So what I do over here is, let me go over the code once again. When I detect a button press through this while subroutine, I just go ahead and write into that pin 5, which is going to be an LED, a 1, and if I detect a button depressed, then in that case I'm going to send a 0 to that pin position. Let me remove some of those variables here that I don't need. I don't need a counter to be initialized, so I just deleted those contents. Now I'm gonna be needing some code to write into that terminal. So let me go ahead and write that down. So when I start the code, I need this to be displayed at the output. So I need a HAL statement before I go into the while statement, because I don't want to repeat that all the time. I go into this part at the top, user code begin to, user code end to part, and I click here and write here HAL UART transmit. That's the procedure that writes into the UART port 2. This is the UART port 2. The content that is specified in the TX buffer, how many characters are going to be written into that slot, is going to be in this line. So there's a one-time string to be written to the outside. The next thing that I want to write every time I click a button, it's going to be something like that. After I turn on the LED, I have to do an HAL. That's going to be UART transmit. So I can check what else I can write in HAL UART by pressing Ctrl and space. HAL UART transmit, as you see here, there is one transmit. There you need a UART handle type. So I click on that. That's going to be HUART2. I replace that with that content, and at this time this can be press button or TX buffer. I choose press button end. I choose the size to be that can be a numerical value, so I set up a size, and the timeout can be any value between 1 to 10, so I can choose that to be 5. Okay, I'm fine with that. So if that's okay, I compile my code. I don't have anything else left, so I just build my project from here. I build the project. Hopefully no errors come out. As you see, I have no errors, and I run the code and make sure that it runs on my computer as well. Now I need to also watch my terminal once I run it. So once I run the code, I expect some outputs to be seen at the COM6 port. Okay, as you see, I have my first statement written on the PuTTY screen. Okay, as you see here. And next, when I press the button, I would like some changes to be made on the output. So you press the button once again. So every time I press a button, as you see, a statement is written on the screen. Okay, so that was a short example on how we can incorporate the COM port on our PC to communicate with our screen so that we can see some outputs. Okay, thank you for listening. See you later. Bye bye.